In today's world, data is the new oil, fueling the engines of innovation, decision-making, and progress. But as we increasingly rely on big data and algorithms to make critical decisions, from job screening to loan approvals, from criminal justice to healthcare, there is a growing concern. What if these systems aren't as objective as we think? What if they are biased? Hi everyone, this is Dr. Giordano Scarciotti, and today we're diving into a topic that's both fascinating and crucial: the hidden biases in big data and algorithms. In this video, we will explore how biases can creep into these systems, the implication for fairness and accuracy, and why transparency in algorithms is more important than ever. Before we get into biases, let's first clarify what we mean by big data and algorithms. Big data refers to the vast amount of information generated every second. Everything from social media posts to online transactions, from GPS signals to health records. It's data that's too large, too complex, and too dynamic for traditional data processing methods to handle. Algorithms, on the other hand, are sets of rules or instructions that a computer follows to perform tasks or make decisions. In the context of big data, algorithms help us process and analyze this massive amount of data to uncover patterns, make predictions, and automate decisions. These algorithms are increasingly being used in various fields, from determining credit scores to diagnosing diseases, from setting insurance premiums to deciding parole outcomes. But here's the thing: while algorithms may seem like cold, hard logic, they are not immune to bias. Biases can enter the big data ecosystem at multiple points. Let's break it down. First, there is bias in data collection. The data we collect often reflects the world as it is, complete with all its inequalities and prejudices. For example, if we are training a facial recognition system using mostly images of light-skinned people, the system will likely perform poorly on darker-skinned individuals. Another example is the data gathered for predictive policing. If law enforcement agencies have historically over-policed certain neighborhoods, the data will reflect higher crime rates in those areas, leading to a feedback loop where those neighborhoods are continuously targeted. Next, we have bias in data selection and labeling. When data scientists choose which data to use, they may unintentionally introduce bias by excluding or including certain type of data. Moreover, the way data is labeled, especially when done by humans, can also be biased. For instance, labeling an image dataset for a computer vision project may involve subjective judgments about what constitutes a violent scene. Then there is bias in algorithmic development and training. Algorithms learn from the data they are trained on, and if the data is biased, then algorithms will likely learn and perpetuate those biases. For example, a hiring algorithm trained on historical employment data might favor male candidates if men were predominantly hired in the past. Finally, we have bias in real-world application and feedback loops. When algorithms are deployed, they interact with real-world systems, sometimes reinforcing existing biases. For example, a recommendation system on a video platform may promote content that aligns with popular but biased views, thereby amplifying those biases further. So as you can see, biases can seep into big data and algorithms at every stage, from data collection to deployment of the algorithm in the real world. The consequences of biased algorithms can be profound and far-reaching, affecting individuals and society in a significant way. Let's look at some examples. Consider a patient misdiagnosed by an AI system trained predominantly on data from a specific demographic. In the criminal justice system, biased algorithms could lead to harsher sentences for certain groups of people, increasing existing inequalities. For instance, in 2016, a ProPublica investigation revealed that a widely used criminal risk assessment algorithm was biased against African Americans. The algorithm was almost twice as likely to falsely label black defendants as high risk compared to white defendants. Similarly, in healthcare, an algorithm used to allocate healthcare resources was found to be biased against black patients, leading to undertreatment. This happened because the algorithm used healthcare cost as a proxy for health needs, and since black patients historically have had less access to healthcare, the costs were lower, leading to the algorithm to underestimate their needs. These are just a few examples, but they highlight a critical issue. When algorithms are biased, they can perpetuate and even amplify social inequalities, leading to unfair and inaccurate outcomes. Given this risk, how can we mitigate the biases in big data and algorithms? One crucial step is ensuring transparency and accountability in the development and deployment of these systems. Transparency means making the inner workings of algorithms visible and understandable, both to the developers and to the public. This involves documenting how the algorithm was created, what data it was trained on, and how decisions are made. However, many algorithms are considered black boxes because their decision-making processes are not easily interpretable. Imagine a scenario where a person is denied a loan by an algorithm, but neither the person nor the lending institution can explain why. This lack of transparency not only erodes trust, but also makes it difficult to identify and correct biases. Another important aspect is accountability. This means holding developers, companies, and institutions responsible for the outcomes of their algorithms. One approach is conducting algorithmic audits, where independent parties review and assess the algorithms for biases and fairness. Some companies are already taking steps in this direction. For instance, Google has introduced model cards, which are sort of identity cards, so documents that provide detailed information about the performance of the algorithm, including any potential bias. This is a step towards greater transparency and accountability in AI development. Another way to combat bias is through diversity in both data and teams that build the algorithms. When the teams building these algorithms come from diverse backgrounds, they are more likely to identify and address biases than others may miss. This includes diversity in terms of race, gender, socioeconomic status, and even disciplinary background. Similarly, using diverse and representative datasets can help indicate bias. This means actively seeking out and including data from underrepresented groups and being mindful of the historical and social context that data comes from. For example, researchers working on facial recognition technology have begun to include more diverse datasets, leading to improved accuracy across different skin tones and facial features. This not only reduces bias, but also enhances the overall fairness and reliability of the algorithm. As we move forward, it's crucial that we think about the ethical implications of the technologies we are building. This includes considering questions of fairness, justice, and equality. One framework that's gaining traction is the concept of ethical AI. This involves designing and developing AI systems in ways that are fair, transparent, accountable, and inclusive. It also means engaging with the broader public in discussions about how these technologies should be used and regulated. For instance, there is growing interest in the idea of algorithmic fairness, which seeks to ensure that algorithms treat all individuals and groups fairly without discrimination. This can involve techniques like reweighting data to ensure fairness, or designing algorithms that explicitly take fairness into account during the decision-making process. So what can we do as individuals? First, be aware of the potential biases in the technologies you use every day. Question how decisions are being made and advocate for greater transparencies and fairness in algorithms. Whether you are a developer, a policymaker, or simply a concerned citizen, you have a role to play in shaping a future where technology serves all of us, not just a privileged few. The hidden biases in big data and algorithms are not just technical issues, they are deeply intertwined with societal values and ethics. As we continue to advance in this digital age, it's vital that we recognize and address these biases to ensure that the future of AI is one that benefits everyone. Thank you for joining me today. If you found this video insightful, don't forget to like, subscribe, and share it with others who might be interested. And if you have any questions or thoughts, feel free to leave them in the comments below. Keep learning, stay critical, and stay curious.